In the 2015 higher level paper in question 1, we were given the iodine thiosulphate titration. So to begin with the calculations for this, we're going to go through and just identify what chemicals each number in the question belongs to. So to determine the concentration of a sodium thiosulphate solution, a student titrated it against 25 ml portions of iodine solution, standard iodine solution. So that's our iodine in yellow. Given that there were 6.35 grams of iodine, so that's still belonging to the iodine, in 500 mils, calculate the number of moles of iodine in each portion, the number of moles of sodium thiosulphate required to reduce this quantity of iodine, the concentration of the sodium thiosulphate solution in moles per litre, 17.85 mils of which were required to reduce the 25 mils of iodine. So we should be able to see there that the 17.85 mils is talking about the sodium thiosulphate, this chemical up here. And then we're asked the concentration of the sodium thiosulphate solution in grams per litre of its crystals, and we're given a formula for the crystals there. So we've all the numbers involved highlighted, and they're matched up with the chemical they belong to. So we're going to begin with D part 1, and given that there were 6.35 grams of iodine in 500 mils of the iodine solution, calculate the number of moles of iodine in each 25 ml portion. So what I want is moles per 25 mils of iodine. What I have in terms of iodine is 6.35 grams per 500 mils of iodine. So I need to get from what I have to what I want. So I need to turn grams into moles, and I need to turn 500 mils down to 25 mils. So to turn grams into moles, I need to divide by the molecular mass of iodine. And that's 2 127s, which is 254. So I need to take my 6.35 and divide it by 254, and that gives 0.025 moles per, now I still have 500 mils of iodine. So I'm nearly there. I have moles in 500 mils, but I want moles in 25 mils. So to get to moles in 25 mils, I'm going to divide by 500 and multiply by 25. And that is 0.00125 moles per 25 mils of iodine, which is what I wanted, the number of moles of iodine in 25 mils. Next, what we're being asked is the number of moles of sodium thiosulphate required to reduce this quantity of iodine. So we're talking in terms of iodine, but we want it in terms of sodium thiosulphate. So to go from one chemical to another, we need to look at ratios. So if I want the ratio between iodine and thiosulphate, I go up to my balanced equation, and I see that iodine has a 1 in front of it, and thiosulphate has a 2, so it's 1 is to 2. 1 is to 2. And I also know I had, going a bit haywire there, I had 0.00125 moles of iodine. So to turn that into moles of thiosulphate, I need to double it, 0.0025. That's how many moles of thiosulphate we needed. So I have 0.0025 moles of thiosulphate. That's what the question asked for. Finished. Part 3 then, the concentration of the sodium thiosulphate in moles per litre, 17.85 mils of which were required to reduce the iodine solution. So the amount of iodine I have, the number of moles, 0.0025, 0.0025. That is moles per 17.85 mils. Of thiosulphate S2O4. Oh, sorry, S2O3, isn't it? Yeah. I've done that everywhere. Not to worry. Right, S2O3 2 minus. Yeah? Yeah. So I want that in moles per litre. So to turn that into moles in a litre, I need to divide by 17.85 and multiply it by 1,000. And that gives me 0.07, yeah, moles per litre of thiosulphate. That's that finished. And then finally, the concentration of the sodium thiosulphate solution in grams per litre of its crystals. So I need to turn this moles per litre value into grams per litre, which means multiplying by the molecular mass. And the molecular mass is Na2S2O3 dot, it's from here, dot 5H2O. So that means I have 2 23s, 2 32s, 3 16s, and 5 18s. Water is 18. And that gives 248. So I need to multiply my 0.07 by 248. And that gives 17.36 grams per litre of my, of my thiosulphate. It should really be the full crystal structure though, so Na2S2O3 dot 5H2O. And that's that finished.